All right, here we go. 2.6, we're just going to be throwing in some inequalities to systems of equations. Let's do it. All right, so here we are with solving systems of linear inequalities. And believe it or not, there's not that much new stuff here. So all you really have to do is take each graph and graph it, or take each equation, graph it, and then you'll shade either above or below it, whether it's greater than or equal to. And then the solution is whenever you have two overlapping shaded parts. That's it. So you're going to graph two lines and figure out where they intersect or where they overlap. And that's all that we're doing this time. So let's try some examples and see how it goes. All right, we're looking at number one here. And basically, you're going to take all of these equations and turn them into y equals mx or slope-intercept form, because that's kind of the easiest way to graph them. You can also just throw in a bunch of points and graph it on there. Either one works. So we've got y equals mx plus b. So that b is our y-intercept. So we've got a point -1, and then we'll put the negative sign with that one. So we'll go down 2, 1, 2, and then over 3, 1, 2, 3. And then down 2, over 1, 2, 3. So then you just connect all of this, and there is your first point. So, and we'll put some arrows on it. So now, once we have this part, we have the line graphed, but sometimes it gets confusing about, okay, do I shade below it or above it? I don't know. So always just pick a point. Generally I'd pick a point that is easy to work with. So 0, 0. And this point is above the line. Okay, cool. So if we plug 0, 0 into this, we're going to see if that's a true statement. So we're plugging 0, 0 into there. So we've got 0 is less than or equal to, that turns to 0 to -1. So the question is 0 less than or equal to -1? And the answer is no, it is not. So that means that we're not shading above, but we are shading below. So there's our first line. So we'll move some of this stuff out of the way. So then our second line, again, y equals mx, 1 over 2, plus b, the -8 is our y-intercept. So we're going to go down here to 8. 1, 2, 3, 4, 5, 6, 7, 8. And then our slope is going to be up 1 and over 2. So up 1 over 2. Up 1 over 2. I always like to make a couple of dots. That's just going to help me out to make a better line. So now we're going to do the same thing, and we need to figure out whether we should be shading above or below. So I'm going to pick the same point. We're going to pick the origin just because it's easier to do math with. So that turns into 0. This turns into 0. So now we have 0 is greater than or equal to -8. And again, is that a true statement? Is 0 bigger than or equal to -8? In that case, it is. I almost said it wasn't. So it is. So this line down here, we're going to shade everything above it. So our actual answer is going to be just this part. And then you can label it however you want. The notes here uses an S because it satisfies all conditions. However you want to label it is fine, as long as I can tell that this is the section that is your solution. So all you got to do is graph a line, pick a point above or below it, and then shade. So, hey, we're going to be doing some coloring. Let's do it. Okay, number 2, we're going to follow the same process. We're going to graph both lines. We're going to see what happens. So this is y equals mx plus b. Our y-intercept is at -4. 1, 2, 3, 4. And then our slope is up 3 over 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. So now we draw our line, add some arrows, and then to figure out which side to shade, again, I'm usually always going to stick with the origin, just because, again, those zeros kind of cancel stuff out. So we've got 0 is less than or equal to -4. 0 is not less than -4. The way to think about that, I'd rather have 0 money than owe somebody money. So in that case, that is a false statement. So we're going the opposite direction this way. So then when we want to graph this other one, so number 1, notice that it's not a greater than or equal to. So technically you're supposed to use a dotted line. I'm not going to get really particular about that, but just so you know. So then it says y is greater than -7. So that's kind of like a y equals -7 line that we would do. So we would come down to -7. 1, 2, 3, 4, 5, 6, 7. And it's going to be a horizontal line. Because that's how that works. So then we're going to do the same thing. We're going to pick the origin and see if it's still a true statement. So the origin, there is no x in this equation, so that's fine. So at y equals 0. Is 0 greater than -7? 0 is, in fact, greater than -7, which means that we are shading up this way, which means that our actual answer is that part right there. Okay, number 3, the equations don't start in slope-intercept form. So just algebra until you get there. So for this one, we're going to move that x over. So we're going to have -y is greater than 1 minus x. And then we're going to multiply both sides by 1. There we go. Don't forget to switch your inequality. Then we have -1 plus x. Remember, when you multiply a negative number to the other side of the equation, it hits both numbers. Don't drop your negative sign. Let's see here. Where am I at? Okay, so we've got that. And then I'm going to rearrange this a little bit. So y is less than or equal to, because y equals mx, so I like to have that x first. That way it just kind of triggers my brain to do the right thing. Anyway, so then this next equation, so we've got, we want to get y by itself. So we're going to have 4y is greater than 20 minus x. Then we're going to divide both sides by 4. So y is greater than -1/4 x. So I move the x in front just to get it into x-intercept. And then plus 5. Oh, there's an x there. So now, okay, yes, we have a fraction, but it's okay because it's just a slope. So now we've got our two equations. So if I start with this blue one, we've got y is greater than 5. So 5 is going to be our y-intercept. 1, 2, 3, 4, 5. And then our slope is -1/4. So we're going to go down 1, 1, 2, 3, 4. Down 1, 1, 2, 3, 4. And we will draw that line. Oh, I missed, but that's okay. You get the idea. Okay, so then our first line that we have, y equals 1x minus 1. So our y-intercept is going to be negative 1. And then it's going to be up 1 over 1, up 1 over 1, up 1 over 1. Boop, 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 boop. So there we go. So I forgot to do the shading earlier, but that's okay. You can always just go back and do it. So for this first one here, I'm going to plug my 0, 0 in. And it says it has 0 is less than negative 1. 0 is not less than negative 1. So that part gets shaded down there. So then we're going to go look at our blue one. We plug 0, 0 in there. 0 is greater than 5. 0 is not greater than 5. So this one, we're going to go that way. So our actual answer is, come on, give me a different color. There we go. Is this little section right in there. And that is our solution. So all this other stuff is, I mean, it matters, but this is our solution part right there. So again, if the equation isn't in an easily graphable form, just algebra, it'll be fine. Same old story, different numbers. So here we go. This is not in x slope intercept form. So we're gonna solve for y. So we've got 3y is less than or equal to 18 minus 7x. I'm going to move that x over, all in the same file soup. So we got y divided by less than or equal to. We're going to divide both sides, all numbers, by 3. So we're going to have negative 7 over 3x. And then 18 divided by 3 is 6. Yes, I was looking for a calculator because I just always question it. It's fine. It's fine. And we divided both sides by a negative 3. That was a negative. No, it wasn't. No. It's fine. It's fine. Everything's fine. Okay, everything's fine. Everything's fine. I didn't drop a negative sign. We're good. We're good to go. I promise. Okay, so now we're going to look at this equation. Again, we're going to solve for y. This is why I thought I'd drop a negative sign, but whatever. Anyway, negative 3y less than or equal to, and I'm just going to keep the 2x in front. I am subtracting 2x from both sides, but I'm just going to immediately put it in front because I know that that's where I want it to be anyway. What is that? Plus 9. That 9 is positive. We'll keep it positive. So then we will divide both sides by a negative 3. So our sign switches. So don't forget that, which I just did it wrong. Okay, so then we have y is greater than or equal to a positive 2/3 x minus 3. So negative left over right there. So there we go. Don't forget to switch your signs, and all right, we're good to go. So since I'm already in this color, we'll graph this one first. Y-intercept, negative 3. 1, 2, 3. Slope is 2 over 3. Rise over run. 1, 2. 1, 2, 3. 1, 2. 1, 2, 3. You don't necessarily have to do a whole bunch of lines. It just makes me feel better to get a more accurate picture. You do have to do at least 2 points. Anyway, so while we're here, while we've got the color up, we're going to plug 0 in for it, see where that goes. So that would say 0 is greater than or equal to -3. 0 is greater than 3 because I would rather have 0 money than owe you all $3. So again, this is kind of how I think about it. So there we go. So our next one, our green equation up here, our y-intercept is 6. 1, 2, 3, 4, 5, 6. Our slope is, I'm just going to go down 7 and over 3. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. Oh, how convenient. And especially when it's that long, I'm just going to do that. So then, once again, we're going to take my 0, 0. We're going to plug it in. 0 is less than or equal to 6. That is a true statement. We'll take it. Let's see here. That was my green equation. So we are shading this way, which means our final answer is all of this. So there you go. So I'm going to let you try the last two up there, 5 and 6. I'm going to do this next problem because it's a little different and might as well. So it says, which points are solutions to the system of inequalities below? Check all that apply. And they're referring to those things right there. Now, normally you could like graph it, put all the points on there, but the reality is that you can literally just stick all of these points into both equations and see if they work. See if they return a true value. So that's essentially what we're going to do. So we will start with 1, 1. So when I plug it into that first equation, we got 1 minus 6 times 1 greater than or equal to, or greater than -48. Pretty sure that's going to be yes, but whatever. So the left side is going to end up equaling -5. So yes, -5 is greater than -40. Because again, I would rather be in $5 in debt as opposed to $48 in debt. So then we're going to do the second one. We've got 2 times 1 plus 3 times 1 is less than 9. So 2, so that's going to be 5, is in fact less than 9. So yes, so we would mark that as a potential solution. Okay, so then we're going to try 9, 2. So we'll go, actually, let's just, so if we were to try 9, 2, we're going to plug that in. Nine minus 6 times 2 greater than -48. That's going to be 12. So 9 minus 12. So that's going to be a yes. Then if I plug in for our next equation, we've got 2 times 9 plus 3 times 2 is less than 9. So let's check that out. So we've got 18 plus 6 is not less than 9. So that is a no. So we can cross that one off. So we're just going to go through and check all these points. Okay, so after you plug every single point into these two equations, this is what you get left over. So you've got 3 ones that work, 3 that don't. That's all that one is. Okay, this word problem is actually a little bit more interesting because it doesn't really tell us what to do, but it gives us all this information. So it says, to raise money to attend Boy Scout camp, Alec is selling popcorn. Small bags of popcorn sell for $4 each, and large bags sell for $6 each. He needs to earn at least $300 to attend camp. He will also earn a badge if he sells at least 60 bags, a total combination. So we've got two sets of equation, two sets of situations. One, he needs to earn at least $300 to attend camp. The second situation, he needs to sell at least 60 bags to get this, whatever badge this is. Probably a merit badge or something. So that's two separate equations that we're going to make. So we could say our X is going to equal our small bags, and then our Y is going to equal our large bags. Okay, so it says, let's see here, we're talking about at least $300, so we're looking at dollar amounts. So small bags of popcorn sell for $4, so 4 times X, so $4 times how many small bags he sells, plus large bags sell for $6, 6 times Y. All of that needs to equal 300. Our second equation is if he sells at least 60 bags total, so X plus Y equals 60, he gets the badge or the award. So what we can do is we can graph these using your graph, give two possible combinations of bag of popcorn that Alec can sell to attend camp and earn this badge. So if we graph both of these things and then we figure out where they overlap, that's going to be our answer. So, okay, if we graph this guy right here, turn that into y equals mx. So it looks like we'll have 6y equals, so I used equal signs. We can't use equal, I mean we can, but he just needs at least, he can have more than $300, but he needs to have at least $300. And the same thing with the 60. He needs to sell at least 60 bags. So that's a better way of writing that. Anyway, so we're still rewriting that so we can graph it. So we're going to have negative 4x plus 300. Y is less than or equal to, so negative 4 over 6, I'm dividing both sides by 6, is 2 over 3. X. And then 300 divided by 6 is going to be 50. So then if we have this guy down here, a little bit easier equation, y is greater than or equal to negative x plus 60. So we've got our two different equations. We're going to graph them, do the inequality game, and we will be in good shape. So we're going to say our x-axis, we're going to label that as our small, and then we've got our large. I know my handwriting's great. And we get to set our scale. That's like what we count by. So we need to have like 60 on our y-axis and 50. So we could do by 5s, which means that every other one's going to be 10. So we would go 10, 20, 30, 40, 50, 60, 10, 20, 30, 40, 50, 60, 70. Okay, now we're just going to graph it as soon as I get it back in the screen. I guess I need to be able to see my equations. Okay, so my green one, y-intercept is going to be at 60. And then we're going to go down 1, over 1. Down 1, over 1. So rise over run, so on and so forth. Oh, stop it, line. We'll go for that. Close enough. So now we should probably shade it. So again, we can just throw 0, 0 back into it. So then it would be, is 0 greater than or equal to 60? It is not. So we would shade in that top part. Okay, so our next one is going to be this guy right there. So our y-intercept is going to be 50. And this time we're going down 2, 1, 2, over 3, 1, 2, 3. Down 2, over 3. Down 2, 1, 2, 3. And you'll see they kind of touch, and I can kind of guess where we're going to be shading, but just because if we throw 0, 0 into that equation, we're going to have 0 is greater than or equal to 50. That is not true. So again, we are shading up this way. So to answer the problem, it says, using your graph, give 2 possible combinations of bags of popcorn that Alec can sell to attend camp and earn his badge. You literally just pick any 2 points in this area and you have a right answer. So there could be multiple right answers here, but we could say, I don't know, 1060. That would be in there. And then what about somewhere on the 2020, 2050? Well, okay, 50-20, sorry. So our 2 answers could be 1060. So that would be 10 small bags of popcorn. He would have to sell 10 small bags of popcorn and 60 large. Or you could come down here and say 50 small. So if I were to write the point, 50, 20, 50 small, 20 large. So there you go. Join Scouts, sell popcorn. Let's do it. All right, last but not least, I figured I'd finish out the word problems for you all just because I know how much you love word problems. So here we go. It says Greg needs at least $1.60 for the stamped mail package. He has 28-cent stamps and 4-cent stamps. He can use no more than 24-cent stamps as he only has 1 book left. So step 1, write a system of linear inequalities to represent this situation, then graph. So we're dealing with cost. So we can define our variables. We have x equals 28-cent stamps. We can have y equals 4-cent stamps. And it doesn't matter what letters you use. You can use any letter you want. It's fine. So we're dealing with cost. So remember, each stamp costs like the 28 cents. So if we use those stamps, that cost is going to be X times 0.28. We're using 0.28 because it's 28 cents, not dollars. And our final number is going to be dollars and cents. So we're just basically matching our units to our answer. Anyway, so if we're still dealing with cost, however many 4-cent stamps we're going to use, it's going to be 0.04. Again, 4 cents is 0.04 of $1. So whatever combination of that needs to be bigger than or equal to 1.60. So yeah, that's our first equation. And then our second equation, it says Greg can use no more than 24-cent stamps. He only has one book left. Cool. So in that case, Y, which is our 4-cent stamps, has to be less than or equal to 20. Done. Too easy, right? Okay, so solving this equation, it might look scary, but they're just numbers, they're just decimal points, so just use your calculator, and it'll figure most of the stuff out for you. So we're going to move the X over. So we're going to have Y times 0.04 is greater than or equal to negative 0.28x plus 1.60. So now we're going to divide every single number by 0.04. Oh my goodness. 0.04. And we're going to use our handy dandy calculator to do that work for us. So I'm going to type in 0.28 divided by 0.04. And that number is 7 plus 1.60 divided by 0.04 plus 40 less than or equal to Y. Okay, so now we can graph those and we can figure out what Greg should do. So here we go, moving over to our graph. So we're going to graph that guy first. Our y-intercept is going to be 40. So we're going to go up by 5s again. So every other one, 10, 20, 30, 40. Have a dot. So then this one means down 7 over 1. 1, 2, 3, 4, 5, 6, 7 over 1. Let's see if it'll straighten that out. Except we missed. That's a little bit better. So then our next one, this guy over here, is y is less than or equal to 20. Put a dot at 20 and whoop. We're going to pretend that's at 20. So we can plug 0, 0 in for either one of them. So if we start over here, if we say y is 0 less than or equal to 20? It is. So we're dealing with this part. And then from this equation, throw in 0, 0, y is greater than, 0 is greater than or equal to 40. 0 is not greater than or equal to 40. So we're going to shade this side of the red line. So again, you can pick any point in there and it would be a valid solution. So I'm going to pick an easy one for me to write out. So I could say 515. And we'll do one over here. Oh no, we'll do one right there. 10. Oh, I'm not counting out that far. This is 10, 20, 30. We'll go here. So 30, 10. So we're not done yet. That's not our answer. Our answer is Greg could use 5 28-cent stamps and 15 4-cent stamps, or 30 28-cent stamps and 10 4-cent, these are cents, stamps. Now, granted, since we're doing inequalities here, is this the most efficient way of doing it? No, but, if it's over the postage, post office isn't going to care. But that's when inequalities can be beneficial when we're dealing with things like that. So there you have it. Your word problems are done, and I'll see you in class.